Okay. So I'll just start sharing. Yeah. So good evening, everyone. My name is Samik Darshan Jain. I'm from an Iastronomer candidate.
Good evening. My name is Deves Bharadwaj, and I'm also from Iastronomer Club.
Good evening. My name is Sarah Prasanna and I am also from Astronomy candidate. So today I'm going to explain some facts on asteroids. What are asteroids? Asteroids are small rocky objects that orbit the sun. Although asteroids orbit the sun like planets, they are much smaller than the planets. There are lots of asteroids in our solar system. Most of them are located in the main asteroid belt, a region between the orbits of Mars and Jupiter. Different types of space rocks. Comets are nothing but snowballs made out of dust, rocks, and gases. Meteors are also like asteroids. Dwarf planets. Dwarf planets are not considered as planets. They live far away from the sun. Asteroids. Asteroids are small rocky objects which revolve around the sun. Asteroid belt. The asteroid belt is a region of space populated by millions of asteroids located between the inner and outer planets. Some dwarf planets reside here, such as Sirius. A long time ago, in the early stages of the solar system, rock and dirt circling the sun were joined into planets. How are asteroids a threat? Most of the asteroids and comets in our solar system do not pose any danger to our planet. Asteroids are too large to not impact the Earth seriously. An impact even from an average size asteroid can cause mass devastation and mass extinction of life. How to reduce the danger of asteroids? Find where the asteroids are, track where they are, categorize the different types of asteroids, deflect them from the Earth, and study more about the asteroids. Now, my friend Adav will tell you more interesting facts on asteroid.
Good evening, everybody. Asteroid Day is an annual global event that aims to raise awareness about what can be done to protect the Earth and its people in case of an asteroid strike. So the Asteroid Day is actually it is on June 30th every single day, and it is there because that is the anniversary of the Tunguska event, which is a massive asteroid strike that took place in Siberia, Russia, where more than 2,300 miles of forests were completely destroyed. Thankfully, there was not much loss of life, but it's a prime example of how dangerous asteroid strikes can be to mankind. Asteroid Day is extremely important because it aims to raise public awareness about the asteroid impact hazard. So, it wants to inform the public about the crisis communication actions that need to be taken place at an international level. Because only if we can communicate very quickly about the threat of an asteroid strike, we can neutralize it and make sure that there is not much loss of life or property or any damage at all. History of Asteroid Day. Now, Asteroid Day was formed in 2014 by astrophysicist and famed musician Dr. Brian May. He was actually the guitarist for the rock band Queen, and he was only one of the co-founders. Some of the other co-founders include Apollo 9 asteroids Rusty Schweikart, the physicist Stephen Hawking, as well as many other dignitaries and celebrities. More than 200 astronauts and technologists and artists signed the Asteroid Day Declaration, and it was first conducted in 2015. So Asteroid Day has been celebrated since from 2015 to 2019, but because of the pandemic, it was not celebrated for the last 2 years. And from this time, over 2,000 activities took place on June 30th to celebrate this Asteroid Day across 78 different countries. More than 40 astronauts and cosmonauts participated in these activities. And in 2019, it was officially sanctioned by the United Nations as, as Asteroid Day is officially recognized by the United Nations. It's going to be recognized each year, and it will be sanctioned by the United Nations every single year. Now, there are many different ways to celebrate Asteroid Day, but the best way is to organize an event in your community or in your neighborhood. And you can also watch this movie called 51 Degree North. It was made by this filmmaker named Grigor G. Richters, and it is a simulation on what life on Earth would be after an asteroid strike. And finally, the Asteroid Day organization, it hosts many events, and it's always looking for volunteers to help out in hosting these events. And it's extremely it can be extremely knowledgeable for the people who are volunteering, because it can help them gain much more knowledge and also experience.
So good evening, everyone. So as all my colleagues explained on asteroids, so I'm going to be explaining on missions on asteroids. So we have heard of missions of moons or other planets like Mars or any other missions to another space rock, but an asteroid, well, that's an interesting fact. So as we have heard, so we know that asteroids are an essential building blocks of our solar system. So when spacecraft study these tiny worlds, so we learn more about how our neighboring planets, neighboring space rocks, neighboring moons, or of course, a planet, we can learn more about them. So there are a few successful missions on asteroids. So the first one, which is named after the famous scientist Galileo Galilei. So the name as given is NASA's Galileo spacecraft. So it was the first ever to visit an asteroid, and in fact flew by a few space rocks. So the mission was originally launched on October 18, 1989. So it was from space shuttle Atlantis and arrived on Jupiter on December 7, 1995. It was a humanity's first encounter with an asteroid occurred. So Galileo approached within 997 miles of Gaspra, which is actually an S type of asteroid, which a Gaspra is, and also another asteroid called Ida. Moving on, we also go on another mission called Pioneer 10 as a spacecraft, which was actually joined by embarking on an unnamed asteroid, which was launched on 2nd March 1972. So as these were flyby missions, these were all successful, where all the missions were a flyby to reach another planet or any moon. So as we go on to the Near Shoemaker, a very popular mission. So this Near Shoemaker was a flyby tour also. So but it was first dedicated mission which was launched on February 1996 and entered the orbit of 433 Eros. So you can just say the fact that it could enter the orbit of the asteroid Shu 53, and then it could have collected many information on that. And then we go on to the Cassini mission, another popular mission. So which was lifted out from Earth in 1997, which was an epic rendezvous with the Saturn. It made an remarkable discoveries from the asteroid with the features. So famous discoveries with the Saturn, it made a flyby mission to get more information on the asteroid. What asteroid? So it was a Masersky asteroid. So we found out it's 6.8 miles long. It is 11 kilometers in diameter, and is classified as an S-type asteroid, same as Gaspra. So we go on. We'll go into the Deep Space One. The Deep Space One asteroid is a very popular one. It was originally intended to test an iron engines or a form of spacecraft propulsion. But the mission was extended to fly by an asteroid Braille and Borrelli. The spacecraft was originally launched on 24th, 1998 and flew by Braille on July 29th, 1999. So as we go on more popular missions, which is now called as NASA Stardust mission, is the most famous mission for collecting first sample from a comet and also returning to the Earth with the samples. But the spacecraft, as it was launched in February 17, 1999, it also flew by asteroid Annie Frank. You might have heard Annie Frank from the Second World War in Germany. but no, that's not what it named after. Which was on November 2nd, 2002, before the famous part of its mission. So there were a few other missions which are successfully taken place until these years, called the Rosetta, Deep Impact, New Horizons, Dawn, Hayabusa 2 from the Japanese, and so on. So they were all successful missions which took place in missions for searching the asteroid or the information for them. Next, as we go on for the ongoing mission, which have been launched and still going on to find samples. It's a popular one is OSI-RIS, Origin Spectral Interpretation spacecraft, which is a NASA asteroid study and sample return mission. So this was the mission's primary goal is to obtain a sample of at least 60 grams of 101955 Bennu asteroid. So it's a carbonaceous near Earth asteroid. We can just get it from the fact of the chemical component in them to get more information on the asteroid of how much chemical components are there in space. So now this one, which was launched in Frontiers program in 2006 and Junology in 2011. So it's way back on Earth to deliver the samples it collected from the asteroid Bennu. It will be the expected date or the year is from 2023. The mission was majorly developed by a scientist of University of Arizona, which we'll be getting more information on. Since this is an ongoing mission, so they're not much, but there are still going on of getting more information on them. And any other missions are. So we'll go on to the next one called the future missions. There always need to be future planned missions, which we need to actually plan for. Finding more information on asteroids, on other space rocks, etc., etc. So the nearest future mission which is planned are Psyche orbital mission by NASA. So this is the one 16 Psyche, as we know, is the heaviest M-type asteroid. So as we know, there are different types of asteroid. 16 Psyche is one of the heaviest known, and the Psyche is orbiter mission named after that, and the one thought to be exposed iron core protoplanet. So this is one we have to look after. And the other future missions which are planned in coming later are Hera, Destiny Plus in 2023, and Zengi in 2024. So all these are possible missions which are planned until right now. So we don't know what can be there in other future, what can be there, what can be planned. It can be anything. So as we go on, we all have an opportunity to discover asteroids, as we have an All India Asteroid Search Campaign 2022 for most prestigious project for students, which is collaboration with IASC, International Astronomical Search Collaboration. And as it goes on, you can all be a part of it, where research scientists take part. And the IASC is a citizen science program that provides high quality astronomical data to citizen scientists around the world. These citizen scientists they're able to make original astronomical discoveries and participate in hands-on astronomy. So this means that the data or the images which are which you get in raw form, they're given to you so that you process, and then maybe make an remarkable discovery with the steps they give you how to do, and this is of no cost, obviously. And Asteroid Search Campaign, the primary focus of IISc is to do the Asteroid Search Campaign, which is a month-long event to search asteroids. So as we go on, we students of Space Iastronomer Space Club, thank you for this. And after this, my colleagues from model classes will take on the session. Thank you. Thank you.
Thank you, everybody.
Thank you, everybody.
So, good evening, everyone.
Good evening.
Yeah, good evening, everyone. Thank you, Arav and Samyak, who were before with us. So, for telling about the asteroid and the importance of the Asteroid Day. So, myself is Sheila Allegan and my teammate Nandini.
Hello, I'm Nandini.
Yeah, are from iAstronomers Space Astronomy Club from Space India. We welcome you once again. And now we are going to do a model making activity. So as we know, asteroids are the important building blocks of our solar system, as we can say that the protein for our human body. I just correlated, guys. So when spacecraft study this small world, we learn more about how our neighborhoods were formed. So that is moon, planet, and of course our own planet Earth. So a flurry of spacecraft have already visited the asteroid in the recent decade to piece together the secret of the solar system. And much more missions are launching soon. So today we have chosen an important mission, that is Lucy. So me and Nandini will take you through the whole model making activity of Lucy. So let's have a look what this mission is all about. So Nandini, can we play a video?
Sure.
The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Eurybates, Ptolemy, Lucas, and Orus. And from this, we're going to sample the diversity in sizes and colors and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
So we hope that you have now and have enough insight about the mission Lucy. So now we are going to make a model of Lucy spacecraft. So Nandini, we are ready?
Yes, we're ready.
So let's begin the activity. So guys, I'll tell you, the basic equipments are very simple. All we need is the template, okay, of the Lucy, Lucy spacecraft. And then you require a scissor, glue, or a tape. Okay. So now I will hand over to Nandini. She will take it forward.
So the template has been shared with you all. And in this template, there is the spacecraft bus, the IPP or the instrument pointing machine, and there is also the high gain antenna. And here you all can see the right solar panel and the right support strut, while here you all can see the left solar panel and the left support strut. So we are going to cut all these parts and then assemble them together.
So Nandini, tell me one thing. I can see a lot of holes here. So can you explain?
Basically, there are two types of folds which we will be needing, the mountain folds and the valley folds. So suppose this is a sheet of paper, then if I fold it like this, then this is mountain fold because it is shaped like a mountain and its peak is facing upwards. While in this sheet of paper, if I fold it like suppose this, so we call this a valley fold because it is shaped like V and the edge is facing downwards.
So you mean to say it's vice versa, right?
Yes, it looks vice versa. So now we are going to cut one of the parts in the template and we are going to assemble them together. So
Nandini, 1 second. I just want to know, you just showed the template, right? So just tell me how, because I can see a lot of dotted lines and the lines. So we have to be very careful while we are cutting and how to go about it.
Yes. So here, as you all can see, there are many dotted lines. So the dotted lines are given mainly for the folds. So when we cut it, we need to follow the straight lines given and the solid lines. If we use the dotted lines, then the result will not come out as we please. So after cutting it, I have like one of the support struts here. So for the support strut, I need to do a mountain fold like this and then do 2 valley folds on either sides.
So it looks like a rocket, right, Nandini?
Yes. And then I also need to do 2 valley folds at its back. So this is how a support strut should look. And for the high gain antenna, this is a high gain antenna. So we need to be very careful because if we cut off this white portion in the high gain antenna, then the result will not come out as we please. So this will mainly provide support to the model. So we will overlap this white section with this and stick it.
So when we stick it, we will get that cone shape of the antenna, Nandini?
Yes. So after I have stuck it, it looks like this. And then I have to stick these two together. So I need to apply glue here and then stick it together. So after I have stuck it together, it is looking like this.
Okay.
And now we are going to assemble the IPP. So this is one of the most complicated parts we need to assemble. So we need to do valley folds in all the dotted lines given. And then we need to put them together like this. And then stick it. So after we have stuck it.
Can I use a tape or a glue? Or like
for this you can use both a tape and a glue, but I have told glue because glue is easily accessible and we don't know the strength of the tape or if the tape can withhold all this paperwork. So after we have stuck it like this, the IPP will look like this.
Okay, so it looks like an envelope, right?
Yes, it looks almost like an envelope. And now we are going to assemble the main body of the spacecraft, that is the spacecraft bus. So we are going to do a mountain folds in all the dotted lines present, and then we are going to stick it together. So after we stick it together like this, it will form like cuboid, and the end result will come out like this.
Okay.
And then we are going to assemble the solar panels. So I will assemble only one solar panel right now in front of you, and you all need to do the other one by yourselves. So this is the right solar panel. So basically you have to put glue over here, like I'm doing it right now, and then paste it together. So when we paste it together, be careful that these two parts are not pasted together. And you have to do the same thing for the left solar panel too. And that's all the parts of the spacecraft. So are you all ready to integrate it?
Yeah, I'll just tell. So these are the components. So we have 7 components ready with us right now. Nandini is ready with the spacecraft bus, the IPP, that is instrument pointing platform, high gain antenna, the left solar panel, the right solar panel.
So now we are going to stick all of these parts together. So first we are going to stick the high gain antenna to the spacecraft bus. So in the spacecraft bus, we need to stick it at the front of the spacecraft bus. But the problem is, how will we determine which is the front of the spacecraft bus?
Yeah, that was the question I was going to ask you. Yes.
So we need to notice that these two window-like structures will be at the top, and this one will be slightly in front of the other one. So as we can see, so this should be the front.
So you mean to say we have to keep it upward, right?
Yes. So I'm going to quickly stick it together. And now the second part we will be sticking are the support struts. So mainly we need to place glue over here and then stick it together. One in this side and the other one in the other. So after, let me stick it with you all.
So guys, till Nandini is sticking it, I'll just tell you about the antenna. So what the antenna does, it will receive all the signals and it will pass it to Earth. So it is a communicable device which will connect the spacecraft and Earth.
So I have stuck the support struts on both of the sides, and now we need to stick the solar panels. So the solar panels which we had kept ready, we need to put glue on this side and then stick it together.
Okay, Nandini, how I will know that which side I have to stick it? The solar panel. So what?
In the solar panels, what I had done is that I had marked which, when I had cut the parts, I had marked at the back like left and right. And after that, when I had stuck them both together, since I cannot open it and see it, I had kept both in different sides. So I think you all can do the same. Because
so you mean to say that the web thing comes upward, right? So that's how it should be. Yeah, okay.
So we have to stick both of them, like one in this side, the other one in the other. So let me quickly stick it. So one is in this side.
Great. So this whole shred will go inside the solar panel, right?
Yes.
Okay. And then we have to stick that 2 wings of the solar panel with the craft, the bus.
Yes.
So guys, this is really easy. You must try it and you must make a sample, and then keep it at your home, I think. Yeah, Nandini, it's looking great.
After sticking it, since it's not dry yet, it's a bit, but you all need to give time for it to dry or else it won't. And then after this, you all need to stick the IPP on top of the spacecraft bus.
Okay.
Let me just quickly stick it. So after sticking it, I come up with a result of like this.
Wow, that looks great. Yeah.
So this is the model.
So hope guys, it is easy, and Nandini has made it look very easy because we have gone through the whole process. So okay guys, so hope you all have enjoyed the activity. Okay.
And if you all have any doubts, then you all can ask us right now.
Yes. So as my colleagues previously told, so these missions are basically to find the impact and to, divert the whole asteroid. So we should know the importance of today's day. And it is just to create an awareness to all of you, and hope we have done our thing. And Nandini, you have done the whole thing really so easy. It's so simple. First I was thinking it's so complicated, so complex, but it looked really simple. All is that we have to keep the template in place, right Nandini?
Yes.
And then cut it properly. So guys, if you have any questions, any doubt, you can ask us. So, okay, guys. So, me and Nandini is going to sign off, right, Nandini?
Yes. So, thank you again for joining, and have a great evening ahead.
Yeah, thank you, guys. Thank you for joining us, and have a great evening.